length and midpoint of a line segment. So there's no need to memorize these formulas. They are usually given to you on a formula sheet. You just need to know how to do them by hand and in the CAS as well. They're actually not as complicated as they initially look. So our distance formula is really just using Pythagoras. You can see that on the right, where our a and b values are actually just x2 minus x1 and y2 minus y1. The difference between the height and width, I guess, if you think of the triangle, or the base of the triangle that you're creating between 2 points. Midpoint really is just the average of your x values and the average of your y values. So it's nothing too complicated, but let's get into some questions with some number work. Find the exact distance between each pair of points. Leave your answer as assert. So here we're going to do our x1 minus y1. So I'm going to actually do these as x1, I'll do this as x1, y1, and x2, y2. So just getting those values right. And really, we're just doing the difference between these. So 1 minus 0 and 7 minus 2. We could do it the other way around, similar to what we have looked at with gradient. Doesn't really matter how we label those as long as we get them attached to each other in the correct form. So the 1s with the 1s and the 2s with the 2s. So we would then get 1 squared plus, actually I'm going to do it all in one line. So 1 plus, so 7 minus 2 is 5. 5 squared is 25. So we'd get the square root of 26 as our final answer. We cannot simplify that. That is the exact value. The decimal would be less accurate, and it's not asking for any decimal places, so we leave it in that form. In fact, it does state it as leave it as assert. Let's do this next one a little bit quicker again. So let's go with 4 minus negative 3 and negative 1 minus 8. So that's going to become a plus there. So 4 plus 3 is 7, and 7 squared is 49. And negative 1 minus 8 is negative 9, but then negative 9 squared becomes positive 81. So it's important to just be careful with your negatives. Remember that squaring a negative becomes a positive, and that is the square root of 130. So that's as simple as we can get that one. Just to be really clear on this as well, you will be expected eventually to simplify surds. So let's say you had a result of square root 8. That's the same as square root 4 times 2. And we can actually calculate the square root of 4. So that becomes 2 root 2. So square root of 8 is the same as 2 root 2. And it's eventually expected that you're simplifying surds. If you know how to do that now, go for it. Example 2, find the midpoint of the line segment joining these two coordinates or sets of coordinates. Previously, we were subtracting one value from the other to find distance because we were finding the difference in these coordinates. Here we're finding the average between these coordinates. So negative 3 plus 2 and negative 5 plus 8. That leaves us with negative 1 over 2, and negative 5 plus 8 is 3, so 3 over 2. That's it. Find the values of a if the distance between 2a and 4, 9 is root 5. Really, really good question, this one. So let's start by doing 4 minus 2, and I'm going to do 9 minus a. I could do that a couple of different ways. Now, 9 minus a squared is the same as 9 minus a bracket and another 9 minus a bracket. That's an important feature of this question, and you'll see why in just a moment. So big square root sign. 4 minus 2 is 2. 2 squared is 4. And I need to expand this now. So 9 times 9 is 81. 9 times negative a is negative 9a. And negative a times 9 is negative 9a. What that gives us is negative 18a plus a squared. So hopefully that's making a bit of sense. So just be careful with your expansion there. Let's do a bit of tidying up from here. So that's going to be 85 minus, in fact, let's tidy it up a little bit. So a squared I'll put at the front minus 18a plus 85. We can then do a square of both sides, giving us 5 equals a squared minus 18a plus 85. Subtracting 5 from both sides gets us to 0. A squared minus 18a plus 80. Now, this is factorizing. I'm hoping you're remembering some of this. We're looking for factor pairs of 80 that add or subtract in this case, to negative 18. So what that would be is, to factorize, it would become a minus 10 and a minus 8, leaving us with a equaling positive 10 and 8. So that's actually solving a quadratic. It's a little bit complicated. If that part is confusing, don't worry too much about that. We cover that in a lot of detail this year. But yeah, we just need to factorize and solve from there. So why are we getting two answers? If you have a look at our little sketch on the right, if we had that coordinate 4, 9, kind of off to the right there, we could have two different a values, 10 and 8, that would achieve a distance of root 5. That's why we're getting those two solutions. So yeah, just worth knowing that you have to be a bit careful. There was a hint in the question that it said find the values of a. It was telling us that we were looking for two values of a, not just one. Good question.